Hi everyone, in this video I'll show some typical usage of spherical coordinates in triple integration. First look at the definition of spherical coordinates. Here's the definition. It's one of the ways how you can introduce the spherical coordinates. There are some other ways, but that's the one which we're going to use. The parameters involved here, spherical parameters. Here we use Greek letters to denote the spherical parameters, rho, phi, theta. They come from a certain ranges, and that's the ranges they're coming from. Rho, which is called the radius, it takes non-negative values. Theta, which is called longitude angle, it takes values between 0 and 2 pi. And phi, which is called latitude angle, it takes values between 0 and pi. I will show you visualization for several standard 3D constructions associated with the spherical coordinates. First, I ask you to look at the level planes. Three level planes associated with these spherical coordinates. First level plane is the rho equal constant. In 3D, in XYZ space, a rho equal constant plane becomes a sphere of constant radius centered at the origin, like shown in the video right now. Another level plane, theta equal constant. In XYZ space, this plane is given by a radial plane which comes out of the z-axis, like shown in the video right now. And finally, level plane phi equal constant. In XYZ plane, it is given by a cone. It's the cone which grows upwards in the positive direction of z-axis when phi angle between 0 and pi and 2, and that's the cone which grows downwards towards the negative direction of z-axis when phi angle comes from the range pi on 2 and pi. Okay, in the last part of this video I'll show you some typical domains, typical volumes, which are given by simple inequalities on spherical parameters. The first one is this one. That's the orange slice of a ball of radius A. Next typical couple of inequalities is like this. They look at the video. This is a ball of radius A from which we removed two cones, one from the north pole and the other one from the south pole. Another typical couple of inequalities which you may encounter is this couple of inequalities. That's the north pole of the ball of radius A cut by the cone with a spread angle alpha, or in a lay language you can call it an ice cream cone. The next couple of inequalities gives you an ice cream cone on the south pole of the same ball of radius A. The last two sets of inequalities, they're more complex, they involve three double inequalities each. Look at this one. The volume associated with these three inequalities is just shown in the video, like so. That's a combination of the orange slice for the angle theta and two cones removed from the north and from the south pole. That's the bounds on the phi angle. And this is another typical three inequalities you may encounter while you do questions with spherical coordinates. And that is again an orange slice, that's the bounds for the theta angle, and that's the orange slice which now taken together with the north pole cone. That's the bounds for the phi angle. Look at the video. This is the volume like so. This is it. This was Denis Potapov. Thank you very much. See you next time.